So I'd like to talk you through a project that I did at school today among all my classes. I should say at school. Everybody was remote because of the risk of flash floods because Tropical Storm Ida is now in our region. Formerly Hurricane Ida, now it's just a tropical storm, but it's still dropping lots and lots and lots of rain. And so, since the schedule and my whole curriculum is off, I thought I'd make something of it. So, a good scientific question that you might ask is how much water is in this storm anyway? It's a nice earth science question. It's a nice, just kind of like a order of magnitude estimate question. And so I thought I'd give the science students one side and the math students the other side. Here's what the science students were doing. Just had to go outside, take some container, and let it collect rain for a while, a couple of hours. I took this big pot. It's got a diameter of about 30 centimeters or so. Put it outside for an hour and 40 minutes, and it collected about 7 ounces or 200 milliliters of water. That's how much rain I collected here. Basically, I just needed a rain gauge, but with the ability to scale it up. So this is the image right now in the early afternoon, but this morning when I was prepping my classes, it looked like this. This is a screenshot of that same weather service, but at 7:30 in the morning, and I've done something to it. This is where the math classes come in. I've made it the background of a document and put a grid over top of it, a spreadsheet really, and with the help of my students, we rated each square in the grid on a scale of 1 to 10, where 0, we would just leave it blank, contains no clouds whatsoever. And then starting with 1 and going to 10, just in terms of how covered that square was with clouds. Really, this isn't cloud cover, this is rainfall, this is the Doppler. So how much area of the northeastern United States is getting rain on it. Now we were able to get an estimate of the size of these. I think it's cut off just a little bit, but basically we were able to find 2 places, a relative number of blocks away from each other, and just get a scale for the size of these. They're somewhere between 400 and 500 square miles each. So if you take that estimate and you put all of those together, just copy and paste that back into a spreadsheet. Here is our very, very terrible computer graphics map of the storm at 7:30 this morning. Add up all these numbers and scale it up so that it's square miles. Turns out that this is about 135,000 square miles, this storm, at least at 7:30 this morning. Looking at it now, I understand there's no regularity to storms. There's no geometrical shortcuts, and the clouds are constantly changing shape and size. Understood. But just for the sake of this being a simple estimate, we're going to say that this storm covers 135,000 square miles. Okay, now back to the rain collection. I had this pot outside for an hour and 40 minutes. It's 100 minutes or 6,000 seconds. Now, the opening itself being 30 centimeters across means that I had a certain fraction, essentially, of the storm. The idea is, if I know the area that I was collecting, that I could make that be a fraction of this entire storm and then scale it up. What would it be like if I had a container that was able to hold the entire 135,000 square miles of the storm? Okay, so just converting everything into the proper units. You can read this if you're interested in all the details, but essentially I just got the area of the opening, divided that by the time, the volume, 200 milliliters, divided that by the time and the area, and I just came up with this number, which I'm calling like the rain flux, which is basically the quantity of rain passing through a certain area per second. So interpreted this way, Every second, at least during the time that I was collecting that rain, every square meter was covered in nearly half a milliliter of rain. Now, if you do other, just measurement experiments in physical science, you might get that there's anywhere from the teens to the 20s of drops of water in a milliliter. And that means that we're looking at like good 10 raindrops per second in a square meter. Okay, anyway, according to an estimate, that would be um, this one, the one that my students helped with. This is just 135,000 square miles converted to square kilometers. We've got 350,000 square kilometers, or 350 billion square meters. Just, MKS, so I can put that with this quantity here. So the storm lasted for days. I know when it was a hurricane, I'm sure it was raining much harder, and it hit Louisiana a couple days ago. I think it was on Sunday. Now it's Wednesday, and it's up in the Mid-Atlantic region, and it's been going for days. But just for imagination's sake, just so we can get a number to say, here's how much it rained today, we're just going to say for 24 hours. Okay, so here's the data we've got. Almost half a milliliter every second over a square meter. Now I'm doing 350 billion square meters, and for one day, it'll be 86,400 seconds. Just have to plug those in. Seconds in this denominator cancels out with that. Meters squared cancels out with that. And I end up with a whopping 14 quadrillion milliliters. Divide by 1,000, convert that to liters. Remember, the density of water is a gram per milliliter, which is a kilogram per liter. And so just divide it by 1,000 again. We're talking 14 billion tons. This is a very, 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 very rough estimate. 14 billion to me just means, okay, so it's 11 digits. The real number may be anywhere, I'd expect, from 10 to 12 digits long. The point is, we're talking about billions of tons of water dumped over a 24-hour period. Over the several days of the storm, we're possibly even looking at hundreds of billions of tons of water in this storm system. That's kind of like a how many grains of sand on the beach question, or how many stars can you see in the sky, or how many blades of grass in the field. These are great ways to exercise simple math, things that I can have middle and high school students help me do, but to get answers to questions that are really beyond our intuition. And, well, I think it's pretty impressive to think of this storm as dumping hundreds of billions of tons of water, at least a dozen or so billion tons of water today. Anyway, if you're in the path of the storm, past, present, or future, I hope that you're well, that you're safe. I don't want to look like I'm happy about a natural disaster, but when it comes to getting students engaged, you gotta play the cards you're dealt. Anyway, there you go.